Okay, so you can see that I've logged into No Machine, which is going to connect to the Big Data University environment. So now I'm connected. I'm just going to set Python to Python 3, which is what I'll be using rather than Python 2, just gets rid of Unicode errors. And unset the Python hash seed, and then attempt to run my file. So my file is word count, which is a Python file. This is all being run through Spark Submit. Here you can see that I've set the Python hash seed to 321. It can really be any variable. But right now I'm just going to show you my actual code so that you can understand what's actually happening when this is running. So here's my code. First off, I'll talk about the configuration settings. So I found that having the executor memory set to 20 gigabytes, the executor cores to 4, and the driver memory set to 20 gigabytes really managed to reduce the running time. It used to be 55 minutes, and I managed to get it down to about 16-17 minutes, which is really impressive. So I'll start off with the methods, which I'll be calling later. First one is clean text, so it takes in an RDD input and essentially removes any punctuation. The next one is frequency, which it also takes in an RDD input. It orders the elements and takes the top 30. So these are the elements with the highest values. The next one is create graph, and it outputs a graph and saves it to my home folder and also to the folder it's currently in. And here we have main. So we read in a JSON file, so it's a Yelp review file. And then we select a field, which is the text field, which is the actual review field that the user has input a lot of text into. We select and map this particular field using map. Then using flat map, we actually convert each character into lowercase. This is important in the counting stage. And then we split the words. Okay, so the next step is to actually call the clean text method, which I created earlier. You can see clean text, it just removes punctuation, which is important. And then finally, next we assign a value of 1, and we map this, and we assign a value of 1 to each word, and this helps later when adding and then reducing. One of the final steps is actually reducing by key, which so you add each value, and you essentially have your word count and you reduce it to find out your final word count for each word. And then here we call the frequency method, which is just getting an output of the top 30 elements or words. And then our final method call is create graph, which outputs a graph, and then we stop our Spark context. So just going back to running the file, I'm just going to run it now. Okay, so the script started running. I'm just going to play it for maybe 10 seconds just to show you what's happening, the different jobs that are running. So we can see here different jobs will be running, different tasks. And here we can see that there are 36 tasks overall. This will take a while. This will probably take another 16-17 minutes, as I said, but it started around 1:01, so I'm just going to skip until the end. I just wanted to note that the output graph will be saved into this directory, and obviously you can see that there are no graphs saved here. It will be a PNG file, so just look out for that. So we can see the program has finished running. There's no errors. It's all completed. So what I want to do is go into that file directory, see if the file is there. Yep, there's a PNG file, word count graph. Click on it. So this graph shows frequency, so how frequent the word occurred on the y-axis, and then we have the actual word on the x-axis, and this, as the title says, is the most frequent words. So after looking at this graph, you can see that most of these words are just words, just neutral words used in most sentences, so there's not a whole lot of interesting stuff going on here. Yeah, but next I will be running problem 2. So this was problem 1, I'll be running problem 2. Thank you for watching.